At this point, you've tackled the basics. So if you're just looking to do the basics, get your basic grade, move along, then great. If you're really looking to become a great programmer, then I encourage you to maybe play along a little bit further and continue to build this next bit. So what I want to do for this next bit is we talked about duplicate tickets. And again, the problem is starting to spiral a little bit. We're not really trying to solve the problems of raffles or whatnot, but let's just say that the requirement was, hey, I need to know not just all the tickets that were entered, but I need to know all the ones that were duplicated. So what do I do to track those? Well, the easy thing I can do is, and this is what we kind of talked about before, is I can have more than one data structure going along here. So I can have a list that goes along with this, which is uh, duplicate tickets or duplicate submissions or all submissions or whatever you want to. But I'm going to do duplicates because I just want to track them separately from, oops, sorry, new array list. I want to track them separately from the tickets that are in the entry. I don't want to have redundant inside of there. And basically, if I want to have everything that was submitted, both the duplicates and the originals, I can dump them into one data structure later on. Um, so how do I manage that? Well, actually, the Java world makes it a little bit easy because when I add a ticket into a set, you see it actually returns a Boolean. Either true, it added the ticket, or false, it didn't add the ticket because the ticket was already there. So I can say if I didn't add the ticket, so if the ticket was not added, then I'm going to go ahead and put into my duplicate tickets the ticket. So as simple as that, I now have everything that was submitted in one category or another, one bucket or another. Um, so when I do the log, then I can actually, I'm just going to format the log. It's just, again, just an outprint here. So I can do out.println, and I'm going to say entries right here. And then I'm going to I'll copy both these lines actually, do out.println duplicates. And so for each, instead of tickets for each, let's do duplicate tickets for each. And so that way I can add in any of the duplicates that get added, and then I can track them. And I mean, just as simple as that, just a couple lines of code, all of a sudden I'm able to see, let's just go to the top here. I have too many of them there. But you can see I have the 4 entries here. So 0, 1, 4, and 14 was the 4 entries that were unique. And then the duplicates is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So all these duplicates that came in between, and so on. So all these duplicates that came up later on. All right, so that very simple little tiny little shift, adding another data structure, is a way of solving problems. It's a way of solving realistic problems out there. For the users, and often fairly costless. I mean, in this case, all I had to do was add in a second data structure and note the fact that, hey, when it doesn't get added to one, I put it in the other. And again, the rationale behind this is if in the set, when I add to a set, we'll learn about this more later on, the first thing I do to see is something already out there. And if it is, I don't add the new one. I add the first one that gets there. So this is still first come, first serve, which is not ideal. I need to know, like, well, for the duplicates, how do I know which one was which? So I have a list of them all, but now let's say I pick a number, and when I pick that number, I end up with 2 or 10 or 50 of that number. Well, how do I know which one is which? So at that point, I might want to be able to search through a data structure to say, hey, what are all the items that are part of this set that matches the pick? And for that one, again, there's 2 choices inside of there. One of them is algorithmic. So let's just add in, this isn't part of the interface, but let's just add in a public, I'd actually do a list here of tickets. And I can say get all of a int for the ticket ID. All right. And within this structure, oops, just ticket, not tickets, just one ticket. Within this structure, then I can solve this problem in a number of different ways. The first easy way is, again, I want to return a list. I don't want to assume there's just one other duplicate. There could be a whole bunch of them. So I can create my list of tickets here, which is we'll call it local duplicates for lack of a better term, because I have duplicates up top. So duplicates, local duplicates, are the duplicates for the ticket ID that I'm looking at, is a new array list. All right. So now I can do for each ticket in the duplicates. So for each ticket in the duplicates is going to dot. Sorry. I'm forgetting my syntax here. Each ticket in the duplicates. So if t dot get, do I have a get? Oh yeah, get number is equal to ticket ID. I could probably make this a byte to be a little bit more resonant with that. That's what the type of the ID is. Then I say local duplicates is equal to dot add t. All right, and then to be a full complete list, then I actually have to get the local ticket, get the ticket from the sorry, the same thing I have to do for the, not the duplicates, but the actual tickets. And then I can return the local duplicates. All right, so that is the algorithmic way to solve the problem. Now, this algorithm requires me to search through all of both lists every time. So it's not the worst. Kind of as a preview of what we'll get to later on, we can actually simplify the logic of this in some ways, if you understand the data structure, and more importantly, not have to loop through and look through every single item on every single list in order to see if there's duplicates. So, I mean, the first list, there could be 10,000 tickets, and I have to look through every single one of them to see if it's a duplicate. The second one, there might be 1,000, or I mean, in this case, the ID is 128. There's only 128 unique IDs inside of there. But whatever that number could be, then I have to look through all those lists. So I'm going to pause there. I haven't tested this yet. It's a little bit harder to test in that you would have to control the list being made and know the number of duplicates, be a bit more intentional in that. But I want to show you this concept as kind of like a little expansion. And most importantly, to be able to show you one more data type before we start getting into C++, before we come back to the data types.